You can go ahead and label it, and then I wrote theorems here, and then just glue this kind of in the center of your page. Okay, so you need out glue, pen, colored pencils, and your notebook. So you can write theorems, and then glue this in kind of in the center of your page. Alright, so notes should be out. You can label it 10-3, arcs and chords. And then we have 3 theorems we're going to be talking about today that we're going to use to help us solve our problems. Okay, remember if you are somebody who is going to prayer, or if you're just gone to the bathroom for a while, or you take a nap during class, expected that you get your notes taken care of. So where can you find your notes if you are gone for an extended period of time? You can copy from ours. What did you say? Oh, from me and our friend. Thank you. Or there are videos on Schoology. Okay. Really important that you're making sure you're getting your notes taken care of, especially if these ones are all like really weirdly specific problems. All right, so with chords and arcs, here we go. We have 3 theorems here. Okay, and this first theorem, DC, you ready? We're going to get started. All right, so in this first theorem, if I know that FG, JH, FG is congruent to JH. First off, if I look at segment FG in the circle, is FG or a chord? F to G? What did you say, Mookie? A chord. Yep, it goes side to side. It doesn't go through the middle, so it's a chord. And I know that FG is congruent to JH. We haven't seen that word congruent in a while. What does congruent mean? They're the same, or they're equal. Yep. What's a symbol we use to show that things are congruent or the same? Equals. What's the symbol we put on the diagram, though? Yeah, the line here, one line here. Or we could do 2 dashes, 2 and 2. Alright, if I know that FG is congruent to JH, then I also know that the measure of the arcs are going to be the same. So the measure of FG, that arc, is going to be equal to the measure of the arc JH. I'm going to zoom in on just that part there. Okay, now this part can be a little goofy with us thinking about that measure. When we say measure, we're not talking about the length, we're talking about the degree from the middle. So if I'm standing at L and I turn, I start looking from F to G. Whatever that measurement is, that's the same as J to H. Because we're traveling the same distance across the circle. So to get to the endpoints, we're going to be turning the same amount of degrees. Alright, this one, what's really important is I want to talk a little bit about those degrees. So the degrees from J to H. What angle am I from J to H? If I had to name that angle. It'd be J to L to H. So when we look at the J to H measurement, we're really looking at this inside angle, that's center. And same thing when I think of F to G, I'm looking at F, L to G. That inside, that central angle is the same. So I'm going to write that here as it's congruent central angles. What does central angle mean again? Where would central angles be located? In the middle. Central, center, at the center. Alright, so that's our first theorem. I'm kind of drawing a box around it because our middle theorem takes a little bit more space. And again, these are just what we're given, things that we could prove. We could take time to write proofs. I know how much you guys love writing proofs. Should we take time to write the proof? I don't think so. You could Google the proof if you really want to. I'm not going to. Alright, in this case, in this circle, if I look at this, AB is what? Is a diameter. Good. What does diameter mean again? What? It goes through the middle and it goes from side to side. Okay, so if I know that AB is a diameter, and it's perpendicular, so does anyone remember what perpendicular means? They cross at how many degrees? 90. It's perpendicular to the chord. So it's perpendicular to, what's our other chord we have in this circle? XY. Then there's two things we know based on that. Okay, so we see that it's perpendicular. We have that 90 degree here. We see that AB is perpendicular to XY. Colors are really meaning not out here other than I'm just showing the different parts. Then we know that AB bisects XY. Haven't seen that word bisect in a while. What does bisect mean? Cut in half. Good. So I know that if AB cuts XY in half, what two parts are going to be the same? What is in half? Yep, the XY is being cut in half. So if I cut this orange in half, it'd be XZ is congruent to ZY. Okay. But we also know that AB bisects the arc. So the arc that connects XY would be the arc XY. When we see that arc, if I wanted to show that on my circle, am I going to go XBY or XAY? What is that arc XY? Is that XBY or XAY? Yeah, why is it going to be the shorter way around? Is it a major or a minor? A minor. Whenever we just see those two letters, it's telling us we just want to take the quickest way around that circle, the shortest way. All right, we have one more problem or one more theorem, and then we have a couple problems we're going to do together. Okay, I'm just weirdly drawing in lines to make sure I know the difference between them. Okay, and this one we're going to start again with the chords being congruent. So if we know that FG is congruent to JH. So we know FG is congruent to JH. Then we know that distance to the center is going to be the same. So from FG, if I go to like the closest I can get to the center, which would be in the middle of that, it's X. X to L is going to be the same as L to Y. And this one we're not really going to do too many, I don't think we're going to do any. We aren't going to do any examples of this one today. It's just one that you on in the chapter, but for today we're not worried too much about that one. It's kind of a goofy one. Alright, I'm going to be passing out the practice problems. I would glue in the practice problems. I don't think you need to cut them apart. I would just glue them in kind of on the left side underneath this. Okay, so I would glue that in right here after you get those written down. We just have 3 practice problems together, and then you have some practice on your own. I would not cut it apart. I would glue it in. I don't think you need, we're going to need some room on the right side, but you don't really need to cut it apart. So I glued it on the left, have some room on the right. This first one is going to be really important just with the way that it looks. It looks a little bit different than what we're used to. What? About 4 more minutes. Remember, it's right at 1:30. Alright, so go ahead and get that glued in. I'm going to glue it in right here. I don't think you need to cut it apart. I think we're good. Going to get started in about 45 seconds. That shouldn't have taken you too long to get that glued in. Yeah, pass this back there. Try and be quick. I'm sharpen my pencil. No. So a lot of these problems are going to be based on looking at your diagram or based on what they give you for information. And then depending on what they give you for information, what can you decide based on that information? So in this first problem, looking at, it doesn't label it, this circle. What information do they give us? Good. FG is 16 degrees. Good. So the measure of arc FG is 116 degrees. What other information do they give us? DE is congruent to... Alright, so I'm going to start by showing our thinking. When you do your practice work, you aren't going to be writing down all these things. You'll probably just write the answer and move on. But for our work today in our notes, we'll kind of show our thinking here. So we start by thinking DE to FG. And our goal is to find what is X. Remember, you should be back from prayer at the 45. Alright, so DE is congruent to FG. And because those are congruent, we know that the measure of the arcs should also be congruent. So the measure of DE, that arc, should be equal to the arc of FG. So I had that FG there, and then DE. Those are going to be the same. Is that 116 is talking about that angle going towards the center. So if I draw an angle from F to the middle and G to the middle, that angle in the middle there is really 116 degrees. That's 116. That's just what it means. That's what this 116 means. It means if we drew an angle, that would be the angle. It's 116. We just don't, sometimes there's just too much going on in a circle to always draw the angle. So sometimes we just put it on the other. So same idea here. This is X. That's really telling us that the arc is X. These are really saying that they're the same amount. So whatever's on the inside, the central angle, that's the same measure as the arc. Same thing here is 116, so that's 116. So what is the measure of DE? We said DE is X, and X equals, what's FG? 116. So in your practice today, it's just going to ask you what's X equal to. And you might see that these are the same, so these are the same. Done.
So we don't solve it?
There's nothing really to solve. It's just saying what X is on that one. This one is a little bit different. Alright, so this one, what is some information that they give us? There's like 4 pieces of information. What's one of the information pieces? The numbers. Like what's 115? JH, that arc, is 115. And HI. So we know that the arcs are congruent. So because the measure of JH is equal to the measure of IH, or HI, so we know that already. That's what's given to us. Because the arcs are congruent or equal, we can say that the chords are also equal. So we can say that IH is going to be the same as JH. Okay, because the arcs are the same, that tells us these chords are the same. Oh, I meant to put congruent there. Sneak a little squiggle in there. Alright, so if I want to solve for x in this one I have to put a little bit more work in because it's not just x. Like this one, it was just x. Makes it easy. This one's a little bit more work. What is JH? That'd be the arc of JH is 115. The segment JH is 2x plus 1. Yep, so 2x plus 1 equals, what's the segment HI equal to the distance? 5x minus 5. And this is where I'm going to do my work off to the side here, because then we have to solve this equation. So this is just really a throwback from algebra at this point. If you feel good about solving this and you want to go for it, go for it. If you're like, what the heck, we haven't done this in so long, follow along. We got it. All right, what was our first step when we solve this type of equation? Yep, we want the x's on the same side. So do you guys want to get rid of the 2x or the 5x? Get rid of the 5x? Okay, sorry, Rama. Yep, it doesn't matter. You should get the same answer. If you want to get rid of the 2x, you can. You'll get the same answer. So 2 minus 5. I can think what's 5 minus 2? 3. And then it's a smaller number minus a bigger number, so negative. So negative 3x plus 1 equals, and what am I left with on this side? Yep, the 5 x's are gone, so just the negative 5. Now we're at that nice cozy two-step equation. So to get rid of an adding 1, subtract 1. So negative 3x equals negative 5 minus 1. So negative 5 and go backwards one more. Negative 6. And then last step. Not just 3. Negative 3, yep. So x equals 2. And we were able to do that because if I saw that those arcs are the same, I know the chords are the same, and I can set up that equation. There's going to be one problem today that's going to ask you to set up an equation like this. It's going to just ask you, the first part, just to type in what the equation is, and then to solve it, you'll have to do it like on a whiteboard, and then just type in your answer. All right, we have one more example. This example is kind of the more complex one. If so far you're like, this is easy. So far you're like, this is hard. Got a couple of things. Okay. So the things that we know is we know that B to E is 12 inches. Okay, if you need to color code that, you can. B to E is 12 inches. We know C to D is 8 inches. But we know that the measure of the arc, CD, is 90 degrees. So this would be an example where drawing that inner angle would just be a lot going on. So that's why sometimes we just say the arc and we put that arc and say 90 degrees next to it. Alright, so BE. What is BE? Is that a radius, a chord, a diameter? Diameter, good. And CD is CD a diameter, radius, or chord? A chord, good. CD is a chord. So this brings us back to our practice. Whoa, I even color-coded this in, not practice our theorem. Okay, when we have a diameter, and there's that 90-degree angle, I know it cuts it in half. So this top XZ is the same as ZY, and this top angle is the same as that bottom angle. Okay? So in this problem here, what is the measure of DE going to be?
90?
I know from C to D is 90. Yeah. What'd you say? Yeah, half. So we're going to take 90 divided by
45.
2, which is 45. Okay, because it bisects it, cuts it in half. What about CF? I know CD, the whole way across is 8. The green diameter bisects it, cuts that orange piece into 2 equal parts. So what is CF going to be? 4. How'd you get that? Yeah, by halving it. 8 divided by 2 gives us 4, and we're measuring in inches. Alright, you guys are like, you said this was going to be a hard one, Miss Morrell. Here we go. Buckle in. Alright, next thing I want to find is what is AF? Crazy. We know that BE, the whole diameter, is how much? 12. So what's half of 12? 6. So we know it's going to be a number less than 6, or it should be a number less than 6, because it's not halfway across. What we're going to do is we're going to add in a radius. So we're going to draw in A to C. What shape is created when we draw in that AC? A triangle. Remember we had a whole chapter about triangles? Wasn't that fun? So fun. So let's draw that triangle over here. We have a 90-degree angle. That's at F. It goes to A. And then up here is C. And we know C to F was how much? 4. Now here's kind of the crazy question we're going to ask ourselves. Super crazy. How long is the radius of the circle? What's the diameter? Frank. What was the diameter? What's the whole way across the circle? 12. So if the whole thing is 12, what's half of the way? 6. So if AB is 6, that means AC is also 6. And we're going to put that X here for that AF. Now what theorem can we use to find a missing side? It's a controversial one. The teacher took credit. The student made it up. Remember that? What? Pythagorean! A squared plus B squared equals C squared. Return of the Pythagorean theorem. And which one is the most important for us when we look at our formula? A, B, or C? Which one is specific? C. What does C have to be? The longest side, or this is from the right angle, the 90 degrees, also known as the hypotenuse. Oh my gosh, so much academic language. So we know it's going to equal 6 squared. Now this 4 and the x, it doesn't matter which one you put it in for. Do we want x to be the A or x to be the B? You want x to be the B? Okay. So that means our A is going to be 4. And then we have to solve that problem. So what is 4 squared? Close, that'd be 4 times 2. Remember 4 squared means 4 times 4, which is 16. 6 squared means 6 times 6, 36. You can't do anything with that x squared yet. So then what do? Subtract 16. So x squared equals, what is, Abdikani? Next time, can we not touch everyone? Thanks. What is 36 minus 16? 20. And then our last step, how am I going to get rid of a squared? Square root. Not divide, square root. It's a little bit different. We're looking for that number times itself. That gives us 20. Square root of 20. Today we're going to be rounding to the nearest hundredth, so 2 places after the decimal. So 4, 7, or round up to 4, 8. What number do we look at for the rounding if we want 2 decimals? The 2, the third one. So does that 2 tell us to stay or round up? Stay. So 4.47. So for our final answer here, AF equals 4.47 inches. So on this one, on your practice, there is one problem where you're going to have to use the Pythagorean theorem. The way it's going to look on your practice is you're going to have to type in your initial equation that you start with, and then you'll solve it like on a whiteboard and just type in your final answer. I didn't want to have all the work. It's a lot to do, you know? All right. Those of you that were gone a little bit, you can come take a picture. Otherwise, I will zoom out so you can get this. Otherwise, you have the rest of the time to work on your practice.